All right, folks. It is 7, and let's get going. A bunch of folks will join in as we go, but they can figure out what they've missed, and we'll catch up based on that.
I'll just save changes, but you finish this at some point, and you're fine and ready to go.
All right. So what we'll do now is let's just get. Let's get going with the blog, and let's start with the first question for today. The first question that we have is, given 2 strings, your goal is to actually check if they are anagrams or not. Is there anyone who has attempted this question, wants to attempt this question?
Yeah. Hello, Vivek.
Hey.
Arpi here.
Go ahead, Arpi.
So to check if 2 strings are anagrams of each other, first I took the first string and put it in set, and then I took the second string, and for each character in the string I removed the element from the set that I created. So if I cannot remove the element, then I throw an error that it is not an anagram, and if after removing all the elements I see that the set is empty, then it's an anagram, and the base, there's this one more check that I put, that if the length of the 2 strings are equal and is not equal, then it's not an anagram.
Okay. Is there anyone who actually has a concern or a question with the solution?
I have a concern.
Okay. Go on.
So, the previous person said that you would put it in a set, right? You're going to put it in a set. So the set can't handle duplicate characters, right? So if I had a word called apple and another word called APLE, both are anagrams according to your algorithm, right?
Yeah. We can also, that's a nice point. I didn't think about that. We can use a hash table in that situation, and we can say, okay, these many letters are there. So key will be the character, and the value will be the count. We can do like that, and if,
Okay.
Hi, this is Sri here. I don't know if this was discussed before, but one of the easier ways is to just have a simple array of let's assume like if it's a 26 character array, and then we can just simply increment each cell of the array represents a character. We can just simply walk through the string and count the number of occurrences of each of the characters, and take the other string and decrement it. So if the array turns out to be a 0 at the end, then both the strings are anagram.
I think that's a very similar solution to the hash solution, but you're right. The advantage of using the counting system, again, you're making an assumption. In an interview, I want to make sure that you're asking the question about what is the, the character set of the word. Are they only lowercase letters, for example? Will they contain other characters? Will they be UTF-8 string of characters, or will that be just like plain ASCII or something like that, right? Because, I mean, if it is just ASCII characters, then you probably might be, you can do that with 255, an array of 255, and just do the same counting. If you think it's, once it goes beyond that, I would not recommend doing the counting approach using an array, but I would rather use like a hash map to do that, or a hash table to do that. All right?
Right, yeah, right. Yeah.
So, RP, your solution about set is spot on, with the exception that you are actually using a set, and by default when you say set, you're automatically losing track of the multiple occurrences.
Right, yeah, I get that point. So a hash table or a map would do, right?
A hash table or a hash map will do. And Pramod, that's an excellent catch.
Yeah.
Okay? All right, awesome. Now what if I actually change the question subtly to say that I want to make it case insensitive, which means that capitalization does not matter. How will you actually handle that?
We will turn it initially into lowercase. So all the characters will be lowercase, and then we'll do the same thing.
Another way to think of the same thing is if you check if it's higher case first, and then subtract it by the difference. So every character in ASCII has subtracted by an offset would give its lowercase, right? Every uppercase character subtracted by an offset would give its corresponding lowercase.
Yeah.
I think it's 48 or something like that. I'm not sure of the exact
32.
offset. 32, yeah. So,
32.
Yeah, 32. So if you subtract by that amount, you would actually get the key of the lowercase, of its corresponding lowercase equivalent. Yeah. That's another way.
But how do you know that you're supposed to subtract or add or do nothing? I mean, that's going to be a challenge.
That's what I said. I would impose a condition first. If a character is between uppercase A and less than lowercase z, I would actually subtract it. Otherwise, I would just go about indexing it.
Got it. Okay, that makes sense. So fantastic. I mean, it's a very easy question, and we will not be taking the time to write this. I'll write the code for this. You should be able to write this code, and typically this should take you somewhere between 7 minutes to 10 minutes. If you are proficient in coding, I mean, coming up with the algorithm should take about a couple of minutes, but then once you're there, about 7 minutes is a good speed. So time yourself when you're writing the code and see and benchmark yourself. All right. If you have already written the code before for this one, prior to this, one of the things I normally recommend is for folks to, when you're doing this coding exercise, always write down like the time you start, and when you're done, write down the time you finish, because it's always helpful to see how fast you're doing. Unfortunately, in an interview, speed matters, and you want to find ways to code faster and faster. So the more you measure your speed, the better your chances are. All right? Cool. Anyone with any questions on the first one? Any concerns, any challenges?
Can we also sort the two strings and then compare?
That's a brilliant question. So which is better, hash table or sorting?
Well, will it depend on the constraints, like amount of memory we can use, or well, if the
so
if it's not ASCII, I guess the hash table can grow pretty large if we have a lot of characters.
That's correct. So Sandeep, I think you've touched on the right point. So if you're using a hash, you're actually using auxiliary space, and the amount of the space that you're using is directly proportional to the number of unique characters that you have, right?
Yes.
Whereas in sorting, typically you are actually assuming that you can do in-place sort.
Yeah.
So which means you don't consume extra space, and it will work as a solution as well. But if you're not permitted to change the string, if the strings are immutable, then actually you have a bigger problem.
Oh yeah, that's true. We'll have to, if you have to sort, you have to convert it to a character array and sort of play with it, I guess. Yeah.
But if it's an immutable thing, then to the part of converting it to a string will cause issues, right?
Yes, that's true. Yeah.
Right. And Gaurav and Raj, you're actually talking about the piece that we just discussed earlier, which was saying that assuming it's just letters and lowercase, it's 26. Assuming it's ASCII or something, then it's 255 or something like that. And assuming it's UTF-8 or like a larger character set, then the array mechanism will not work, because it's just that your data set will be too sparse, so it doesn't make sense to use an array. All right? Excellent discussion so far. Anybody else with any other questions on the first one? All right.
I'm sorry, I missed it because I couldn't find the URL to get in.
Uh-oh.
Yeah, I was just grappling for where's the URL for the board?
The board URL is actually let me actually send it on the conference. Just give me 1 second. I will
Well,
paste it in the chat. Oh, there you go. Thank you, Avdesh.
I'm sorry, I can't find it.
It's on the. Let me post it on the meetup as well. We're using the same board as last time.
I know. I just didn't write it down. It was in an email somewhere, and I was grappling for the email. And what can I say?
Yeah, I have pasted it on the as comments, so you should be able to see it in
Okay, great.
In the meetup. So yeah.
Okay, just a minute.
All right. So now moving on to the second question. Find the first unique letter in a string. So if you're given a huge string, your goal is to actually tell me what is the first unique letter that you got.
I have a solution for this.
Who's this, RP?
RP, yeah.
So I'll wait up. You did the first one, right? So let's hang in there. Let's see if somebody else has a choice.
Mm-hmm.
If nobody else speaks up in the next 5 seconds, it's all you. Anybody who's actually solved this question?
Hey, it's Avdesh here. Yeah. I've kind of solved this problem before.
Hey, Avdesh, can you move your mic a little away from from your mouth? Like
sure.
You're too loud. Go ahead.
Saying I've solved this question before. Approach I've used was to use ASCII array. So just create an array that can contain and from 0 to 128 items, and then start traversing a string. So start traversing each character one by one, and so keep filling the array. If is it capital A, that means set 65 to true. So basically create a Boolean array first.
Mm-hmm.
So basically what I'm trying to do is just setting a flag for a particular index in the array.
Mm-hmm.
And as I'm traversing throughout the string, if I find that at any particular index flag is already set or flag is already true, that means I've already been there on that index. So
Mm-hmm.
I'll just return that. I'll just take that particular value out of, if it says 65, so I know it's capital A.
Mm-hmm.
So I'll just return that error.
This is the opposite question. I'm not asking for the first duplicate letter. I'm asking for the first unique letter, which means that if your input string
Mm-hmm.
was like, I don't know, let me get to the window. So if my input was A, B, C, D, B,
Mm-hmm.
the unique character, the first unique character is D.
Right.
We should probably do the same thing that he told, but instead of Boolean values, you store numbers and keep on adding them. At the end of the after you've done the string once, you again go through the string and see which one of the characters has its value as 1. So that occurs only once.
Right.
So that would be the character you would return.
So we can use in place earlier approach that I was telling, in which I have array of 128 integers this time. So as someone said before me, we can just keep on incrementing index as soon as we encounter the character. But other approach I'm thinking is using again hash table and just use character as a key and number of occurrence of that character as value. And once I traverse the whole string, then go back to the hash table and see which particular key has a count equals to 1.
I was
a bit more.
I think we should store the index of the character since it's asking for the first occurrence.
Who's speaking?
And then this is Shri.
Hey, Shri.
And you should store the index of the character because it's asking for the first non-repeating character. And just like as extrapolating the methods discussed before, we can mark instead of counting, we can just mark the duplicate characters as a negative number or something like that. And then for that is unique, we can mark the index of the character. So we start by marking the index of the character in the array. If it is duplicate, we just change it to a negative value. And then like once this is done, we can pass through the hash and find the minimum index and return that index.
So anybody else with a concern with the approach, or is a better approach?
Well, I have a different approach, but it might be a bit more expensive. May I speak up?
Yeah, we can.
Just 1 second.
We can have two for loops. Run first for loop and have the flag. When it matches the character, skip that character and go for the next one. And when it's not matching the character to throw the string, that is a unique first character. If you run through two for loops.
Okay. So Ramana, the problem that we're discussing is on the blog. We are actually discussing the second question, which is the first unique letter.
Mm-hmm.
Sure.
All right. Yeah. So, thank you. I think the great answers so far. The one concern I have for like most of these things is that that's another question. N log n. This most interviewers, when they ask this question, they would actually automatically add in a constraint saying this is not like a character, but it's like a stream of characters. So which means that you cannot revisit it. So the concept of sorting that SP was suggesting, or the concept of like using a hash table to put this information in and then go back and figure out the value is not permitted. You could do the hash table with the index storing because then you're not revisiting the string. So I think that was a suggestion which might still work, but there are other concerns. So let's go back and.
Can I say one way?
This is Sirisha.
Hi Sirisha, we can finally hear you.
Yeah, so can't we use a map here? Is it a bad idea to use a map?
You could use a map, but what is the time complexity for this?
So you store it in a map because you have to store all the elements like the count in a map. You will have to traverse through the array once. So it will be order of n, and then again we'll have to maintain. Like we would have to again go through the array just to see where the the unique letter is, which is the first unique. Find out all those keys for which the count is 1, and then find out which key occurs first in the array.
So what is the time complexity for this? You will be going through the whole thing all over again, right?
I have a one pass. I have a one pass through the array, but I use 2 data structures to keep track of things, so space complexity is a bit higher.
Mm-hmm. Go on.
Okay. I created basically I created a set, and so what I do is I start off at the beginning of I created a set, and then I created a queue just with a simple array list. Okay? So the idea is the first character you add to the set, and then you add to the array list. Next character, you look. If it's in the set, then you delete it from the array list, and you keep going, and by the end of that, whatever's on the top of the array list is your first unique character. Did you get that?
Mm-hmm. Anybody else with a question or a concern about this approach? Does the approach make sense? If not, ask.
You're going to delete from the array list?
Yes, because if you find the character in the hash set, that means you've already seen it, so it's not unique anymore. So you keep it in the hash set, but you delete it from the array list. So the array list only contains things that are unique. And of course, because they're in the order that they were inserted, the top one is going to be your oldest.
But doesn't the insertion and removal, not insertion, sorry, the removal is again, won't it take like I'm not sure. Like.
Yeah, it will be costly.
Yeah.
Deleting from an array list is actually could be a O of n operation, where n is the number of elements in the array list.
Exactly.
So another variant of this question is actually the last unique letter. I don't know if you've seen that one.
Oh, there is one more way. Hello?
Yeah, go ahead.
Yeah, there is one more way, like Java provides linked hash map. So as per whatever the way we insert into the map, it will store in that order. So whenever we find the same element again, we can remove from the hash map. It's one operation to remove again. So at the end, we have all the unique elements in an order, whatever order the values we encountered. So the first element in the linked hash map would be the first unique element.
So it will fail for the condition, that example that I gave you, right? If there are 3 A's in the example, if you look at line number 20 in the Etherpad, the first A will go into linked hash map, the second A will remove it from the linked hash map, the third A will become the first unique character. Will it not?
Yes, it is.
So I was wondering if you could use a priority queue.
The other way is, instead of removing, we just keep incrementing the count of it, and when we go through the linked hash map, the first number one, the first character with count 1 would be the first unique one.
Correct. That would work. So Gaurav, go ahead.
I was wondering if you could use a priority queue to store the characters, and anytime you find a character, you put in the priority queue with priority 1, and so you have two data structures, a hash map, which points the key to the element in the priority queue, and the priority queue is queued on the number of times the character is seen. So you'll have insert operations, and you'll also have increase key operations. And by the time you're done with seeing, all the characters, the thing on the top of the priority queue would be the first character.
The problem is that in a priority queue, if the priorities are identical, what is the order?
I think it's by insertion, right? I might be wrong about that.
It is by insertion. That is correct. Right. Typically, right? But the problem is that if so that should be fine. Yeah, in this case, you wouldn't have a problem. Let's assume that if the priority queue is maintaining the order of insertion, then you're good.
Yeah. So anything on the top would be the answer.
Yeah, I like the solution that I think Pamela was talking about, which is basically using a set for the counting, which will contain like the data, the histogram, or like how many A's have you seen, how many B's have you seen, kind of a thing. And then you would use a queue which contains the queue of unique elements that you have seen. Of the elements that you have seen so far, that will contain the queue of unique elements, which means the first one will be the first unique element, second will be the second unique element, third one will be third unique element, and so on. The thing that you will do is that if an element is actually, if you find a new element, then what you will be doing is that you will not be evicting the queue, evicting the element from the queue right from the get-go. Like if it's already at the top of the queue, then you'll eliminate it. If it's not, then you just mark it as double and go on. When you're eliminating something from the top of the queue, you will have like elements which are in the queue that may be dirty, and when you're trying to evict it, at that point of time, you could clean it up. So the way, let me just explain that. So
it's similar to what I suggested, except, well, I'm just thinking, except you don't delete as you go. You just delete when it's convenient.
Yes. So you don't. So it's the same thing as the ArrayList solution, but ArrayList deletion is expensive. So we don't want to do that. What we do is that if it's dirty, keep it dirty. That's fine. And only when you evict the top of the queue, the new front of the queue person, check if that's dirty. If it's dirty, then kick that out. Check the next one. If that's dirty, kick that out. Check the next one. Stop when you find a clean element, and you're good to go. So here the cost is not as expensive as what you had.
Can you take an example for that?
Sure. So let's take if you are on the coder on the Etherpad, the example that I have is like a triple A, B, C, C, D, B, right? And I'm just for simplicity, just gonna add X, Y, Z as well, right? So now I put A in the queue. That's the first element, all right?
I'm
now,
not seeing what you. Oh.
Line 22.
Oh, okay, up there.
And it's also on the video if you're looking at the shared screen, because I'm sharing my screen. So this is my set and this is my queue. All right. Set has A equals 1 and queue has A. Then what happens is now I find the second A. So I increment my set A equals 2, and then I kill this from the queue because it's dirty. It's the first element, top of the queue, kill it. So far with me?
Yeah.
Okay. Then I add the third A. Since it's already dirty, I don't care.
Mhm.
Then I add B equals 1. B goes to the top of the queue.
Mhm.
Then I add C equals 1. C goes to the next element in the queue.
Mhm.
Then I add C one more time because it's C equals 2. I do nothing.
Mhm.
Then I add D, and that D goes here. Then I find a B, right?
Mhm.
Now that I found a B, which means that B, D equals 1, B has become 2, right? So now I can evict, I just evict this B from the queue.
Mhm.
Immediately after evicting, I just check if C is dirty or clean. Is C dirty or clean?
Dirty.
So it's dirty.
So kick it. Is D dirty or clean?
Clean.
So wait, all right? And then now I have X equals 1, Y equals 1, Z equals 1. So I just add that in the queue, X, Y, Z, and I'm done.
Yeah. And then the top of the queue is, okay. So it's same idea except different data structure on the queue.
Correct. Yes, RP, you had a question.
So when you had the first day, you put it in the queue, and then second day you removed it from the queue, I think. And third day, so you were like, oh, it is already free, so we do not care about queue.
Ignore. Yep.
Yeah. So the idea is, if you get a second day, then you remove it from queue, right? So
yeah, you remove it from the queue only if it is at the top of the queue.
Oh, only if it is. Yeah.
Because we didn't remove C, right? When we found the second C, we didn't remove it. We waited.
Okay. So once we remove, then we also check, okay, what is the next stop on the queue? If it is dirty, we remove until all the dirties are removed. Okay.
That is correct. So it's an algorithm which actually uses obviously extra space. You're using two different data structures, and it has its own sets of issues. And we have used this thing in a different form. If the question had been the other one.
Wait, first one is a queue or the first one is a set or a map?
A map.
It's a map because I'm counting, but it could have been a set.
Yeah.
Vivek, one question: is it necessary to keep the count?
You don't have to. It could have been a set.
It could have been a Boolean or a dirty. No, it can't be a set.
It's just a set. It can be a set because if it is a set.
You can't.
It's either in there.
It's a dirty set. That's it.
Okay, fine. Okay, I get what.
Because you check and only then insert, right?
Yes.
Yes.
So is A dirty at the very beginning when everything is flushed? Is A dirty? No. Okay. So let me put A in the dirty set now and add it to the queue, because now on, if I get A, it's dirty. Right. From this point forward, if I find another A, then it will be dirty. So it's a dirty set. So original solution involved a set. That's why I had marked it as set. But since for explanation purposes, I had used counting, which is just a little easy and intuitive for us to learn. Here's a flip to the question, which is, if I had asked the question as saying, what is the last unique letter? How would that change your algorithm?
And instead of queue, maybe you pack in the second one.
Then I think you'd want to use a stack.
Yep.
Yep.
I think
Sirisha, right? That's a great answer. Yes, it's actually pretty simple. In case folks had actually come to the in-person classes that we had, this was one of the try questions that we had solved, where it was the question was give me the last unique URL that was streamed, and it was a similar approach. Not a whole lot different, but it's the same thing. So you use a queue if you want to do the first unique. Use a stack if you want to do the last unique. All right. Any questions so far?
So if we talk about the complexity of the set and queue implementation, then it is going to be order of n, because we are going to traverse the string once, and so is same with linked hash map, right? It is going to be order of n.
What is the insertion complexity of a linked hash map? It's not O of 1.
Okay.
And the problem is that to find the unique one at any point of time, you have to traverse to the entire hash map.
Okay. So what will be the complexity of the linked hash map implementation?
The find first unique letter at this point of time query will actually cost you O of n, where n is the number of elements in the hash map, because worst case scenario is that the last element in the hash map is the unique one. Okay. So I don't think the linked hash map solution is not well thought through.
Okay.
This solution is actually convenient in the form because you are using a sort of you could potentially create your own linked hash map, in the sense that you could create a set, and you could create your own linked set where the link is actually giving you the queue.
Yeah. Okay.
So you can't rely on an existing data structure, because the existing data structure does not really help you get to. I mean, the question is not what the linked hash map is supposed to be solving. Linked hash map solves a different problem, and I don't think you can retrofit this to that.
Okay. Thank you.
Okay.
Yeah.
And somebody did mention saying that we can use a DQ, and theoretically you should be able to use it, but actually a single queue would be more than enough. You don't need to use a double-ended queue. Okay. All right. So let's jump to for the last unique letter. Okay. Awesome. Yeah, that should be fine. You could potentially use a queue and then use the end of it, or you could use a stack. Right. That would also work. But yeah, yes, the DQ works. Sorry, I did not tie the answer to the question. My miss. All right. So number 3. Given a string, the goal is to print the rearrangements of the letters, keeping the vowels together. Rearrangements essentially means that it's all permutations. So if I give you simply speaking, I'm at line 68, 69. So if I give you A, B, C, D, then the rearrangement for that would be A, B, D, C, A, D, B, C, and so on and so forth, like C, D, B, A, and everything else. They're like 16 combinations, I guess, or whatever the number is. Since there's only one vowel, it doesn't matter in this case because the vowel is always together. But if I had A, B, C, D, E as the input string given to you, then you have to keep A and E together always. So it could be A, E, B, C, D, E, A, B, C, D, because they could be intertwined or something like that. So that's the question. Any concerns with the question?
Any what on the question? Oh, concerns? No.
Hello? Did I just lose folks?
No.
No.
Just 1 second. Let me just log back in. I think I'm not able to hear folks.
I can hear you.
Yeah, we can hear you.
Hi, this is Roger.
Hello?
Hello?
Hello, Vivek?
Hello?
This is Sirisha.
Are you there?
I think Vivek is trying to log in again, probably.
Yes.
Can the rest of the folks hear me here? This is Sirisha.
Yes.
Yeah,
I hear you.
We can hear you. Yeah. Sorry, I just logged back in. I just lost my I lost my audio. I mean, I was able to speak, I guess.
We could hear you, but you could obviously not hear us.
Yeah. Sorry about that. So I'm back now. All right. So was the question clear?
So Vivek, even the permutations within the vowels are to be counted then?
That is correct. It is an arrangement of the word. So if I look at if I give you I think I gave you the example, right, for that one? So in the example, A, E, B, C, D is a different arrangement and E, A, B, C, D is a different arrangement. In both the arrangements, the vowels are together. So that is a valid arrangement. Those are two different arrangements.
Okay.
Any thoughts?
Yes, thoughts, definitely.
Well, any solutions?
Well, I'm just going to talk about a strategy, and it's very general strategy. What I would do is take all of the vowels and come up with all of the combinations of the vowels by themselves, and then use those as a chunk to generate permutations with all the other characters. Does that make sense? And yes, that's a very general approach, but
yeah.
Other strategy we could do is to check, write a function to see, given a string, whether the vowels are together. So as we generate the permutations, we can check on the string, and then if it doesn't match, then take it out of the generated string.
That works too.
That works, but if I give you a string with like 1,000 vowels and one consonant, you'll be discarding a whole bunch of solutions.
Exactly.
So I could engineer a scenario where what you're doing is not effective.
Can we use dictionary or hash table again to kind of store all the vowels there, and when we traversing characters, and if we just go inside hash table to see if that character is a vowel, then we'll skip it, and if it's if it's not a vowel, then we'll create a new string, and we keep on doing that. And once we traverse the whole string, then we'll go back to the data structure where we actually stored all the vowels that we found, and we append all those vowels at the end of the string.
The vowels need not be at the end of the string.
Yeah, that's why I said you generate all of the permutations of just the vowels.
Yeah.
And then you start generating the permutations of the various consonants, inserting the vowel permutations as a chunk in the various positions. So, for example, on the AE and EA, you've got two vowel combinations. So then you can permute with your consonants using the AE combination in all of logical places, and then you can permute with your other consonants using the EA combination.
So basically, it's like bundling up all the vowels with a single and represent with the letter, say X, capital X, and then finding all the permutation and then replacing X with the possible combinations of the vowel things, right?
Yeah.
So if you have two vowel combinations, then you'd have two values to be substituted for X in all the various places. See, so that keeps all your vowels together.
Yeah.
And I'm just describing an approach, obviously, but
can I ask a question? Will the vowels repeat themselves, or with any characters repeat themselves?
Fantastic. I was actually waiting for somebody to ask that question. Yes, the characters could be repeating, and the vowels could also be repeating.
Yeah.
So in the previous example that we talked about, I think it was Shirisha's suggestion, where I was thinking of a scenario where I give you 1,000,000 A's and 1 B. Okay, there are only two ways to do this. There's only two solutions for it. It's B followed by 1,000,000 A, or 1,000,000 A followed by a B. And what in that case, what you'd be doing is you'd be creating billions of combinations and then eliminating every one of them to finally arrive with the two. So that was what I was thinking, but I did not want to reveal that duplicates are possible till you figure it out. So fantastic. I guess it was Oli who did that. Great job.
So I think if we're going to use hash table,
I was thinking.
One second, Avdesh. 1 second. Oli, go ahead.
Oh no, go ahead. That's fine.
All right, fantastic. All right, Avdesh, your turn.
I was just saying that solution that I suggested, I was trying to use hash table just for that reason, so that we can have duplicates out of the picture. Because by using hash table, we'll just have key character as a key and then number of time it appears. And we don't care how many time it appears. We just need to worry about how many vowels we have in the string. Then we make all possible combination out of those vowels. And
I'm not sure if it will work the same way. You'd have to think about it. Think through it, because I think using a hash map or a hash table to extract the unique characters first, that's fine. But then the problem that you'll run into is that I mean, if you only had, like, ignoring the scenario of having multiple like this whole vowel together thing, right? If I give you ABA, right? Right. You can't just put A in the hash map, say 2, and B in the hash map, say 1, and then you can't say it's like the group of A, B, and BA, right? Those are not the two combinations, which will be AAB and which will be BAA, right? The ABA is also a valid combination. And how will you actually figure it out? Like, your hash map you have to take the elements of a hash map and somehow distribute them also around different places. I don't think the hash map based solution is actually correct. I mean, I'm not probably following your solution, but
okay.
But that's
I think
a couple of minutes ago. So the question that was asked was, were there duplicates, which is what I was suggesting. Somebody just commented on again, unnamed. Please rename yourself so that I can actually address you directly. But yes, the question was, what was the question that was just asked? It was like, can there be duplicates?
So
the answer is, of course, yes.
And ABA is not a valid combination too, because two vowels are separated by a constant.
I messed up. Call it like CAC, all right?
Yeah.
C is 2, right? This is A. In that case, you would actually be saying CA. Right? But whereas CAC would be a valid combination as well.
Yeah, that's valid.
And then you will not do that. How will you do that? How will you know to divide how are you permuting? You're permuting based on the keys of the hash map. So you will never you'll never generate CAC as a combination. Fantastic. So I think Ramya and Shashank, you've been asking quite the right questions. Can we actually use a hash set or a hash map to store the generated permutations and duplicate? It works, but it's not preferred. It's not ideal. It's not the right. It's not the correct thing to do. Like if I give you 1,000,000 A's or 1,000,000 B's and I'm asking you to generate all permutations, there's only one permutation. But what you will be doing is you'll be generating the 1,000,000 factorial combinations, permutations, and then you will be deduping each one of them, right? That won't work. Does that make sense, Ramya and Shashank?
Mm-hmm.
Right. So that's not a good idea. So what else can we do? It solves the problem, Ramana, but it doesn't. There could be duplicates.
Yeah, true. No, I'm just supporting his statement.
Okay.
Sure.
Awesome. So, any other thoughts?
We can do permutations with characters with the collection that contains duplicates, right? We could do.
Yes.
We could find out possible unique permutations in this case.
Okay. So permutation combination questions are actually often asked in interviews in multiple places because they represent like a class of problems that are fairly easy and intuitive to understand. So I'm looking forward to each one of you knowing how to generate permutations, combinations of a given set of characters. You should know how to do that. And if you don't know how to do that, either read up and then try it out, write code to test it out, and then keep repeating. It's something you should know. I mean, there is no excuse for not for that. I mean, you have to know. Now, on this particular scenario, generating permutations when you have duplicate characters available is a very simple algorithm. Essentially, generating permutations is actually more of it's a recursive algorithm. So what you do is that you take one character. What can be the first character in this permutation? Given a string called like something like A, A, B, B, C, C, D, E, F, what do you think can be the first character in the permutation?
A.
It can either be A or B or C or D or E or F.
Yeah, D.
Right. That's it, right?
Yeah.
That's all that's possible. So what you do is that you actually, the next generation is essentially, this is 1, 2, 3, 4, 5, 6, 7, 8, 9 characters long. So what you are trying to do is that you are generating A plus permute of
the rest of the characters.
The rest of the characters without the A.
Yeah.
Then it's B
one
plus
question.
Permute of, just 1 second, Pramod. Okay, of AA without that character, and so on, right? Plus C plus permute of that, and so on. Now the thing is that given the fact that there are two A's, like let me actually just say there's only one C, not two C's. Okay, so then in that case it'll actually be just perm of this without any C in that, and that's about it. So when you do this approach, you are guaranteed to not generate duplicates, right? Yes, whoever is unnamed talking about inbuilt functions in Python for permutation.
That defeats the
yes.
purpose of the question, right?
In most interviews, you will be forbidden to use anything that's inbuilt functions. Otherwise, there are most of these questions like even sorting, right? There's an inbuilt function for sort, but then when the interview is specifically looking for your understanding of sorting algorithms, they will kind of stop you from using an existing one. All right.
I have a question.
Pramod, your question. Sorry, go ahead.
The question was when you actually do A plus perm, you basically you can't call all the letters. You can only call the vowels because you want to pair all the vowels. You want to put all the vowels.
I'm starting with the permutation with repetition question. This is not the answer.
This is not our question. This is not
the question. This is just permutation because looks like we are not sure how to do permutation with repetition, right? So I'm just explaining how permutation works and how repetition. It automatically handles repetition because you only use unique characters that are left in the array to continue your activity. Yes. Okay. So let me go back to Sarah's question. Sarah asked a question. Give me 1 second. Of saying that why is it a bad idea to use like a set to store the results and then use that to get the uniqueness? Is that if I give you like a million A's and with one B in it, right? You will be generating a boatload of combinations which all will be thrown out. Or if you want uniqueness, if I just had A, B, C, D, E, A, E, I, O, U or whatever, right? Millions of vowels and consonants, you will be generating too many duplicates. Okay, so who asked a question? Who was speaking? I interrupted someone.
I had asked a question. When you say A plus perm, the thing you're just concatenating A with permutations generated by the string.
Every permutation that's generated by the whatever's in the parenthesis, I will be prepending an A to it. Right?
Okay.
This is a recursive function for permutation. Now take this and add what Pamela said. Go ahead. Somebody was speaking. Go ahead.
So your first step in your algorithm is to find out the unique characters. Is it? I didn't get
is that Sri?
Yeah. The first step in your algorithm is to find the unique characters, right?
Yeah, the first, it's not the first step, but essentially what we do is that when we do the permutation with repetition scenario, is that you only for all the unique characters in the perm generation scenario. So if you're asking the question of saying get me a permutation for this, right? Then you will be running a loop which essentially will only run once for every unique character. So you'll only be using A, B, C, D, F, regardless of number of A's, number of B's in the string. Right? It doesn't make sense to run for one A, doesn't make sense for run for one B, and doesn't make sense for one C. It's a very simple check. Essentially what you do is you run it for all the characters in the string, and you only do it for when the current character is different from the previous character. That's it.
Okay.
Right? You sort the string and do it when the current character is different from the previous string. Permutation algorithm is very simple. Permutation algorithm is very simple. It's industry standard. Check it out. It's pretty easy. Now going back to original Pamela's suggestion, which was that what we'll do is we'll take all the vowels and replace that with X, right? So now if I give you whatever the vowels are, so if I had this A, B, C, D, E as my input string, essentially what you're doing is you're going to call it X, B, C, D. That's it. Now you generate all possible combinations using X, B, C, D first. Make sense?
Yeah.
And then for each of those combinations, X, B, C, D becomes X, C, B, D, X, D, B, C, and so on and so forth. Then for each of these combinations, what you'll do is you will be generating, so what is X? X is actually equals AE in this case. Yes. So it's actually a set of AE and EA, right? It's both. So what you're doing is, in this case, you will replace X with AE and EA, and you will be generating, again, BCD and BCD. So you will be replacing each of these things with n number of values, and that will work. It's not intuitive. It's not easy. So it's gonna. You'll have to write code and play with the examples to be a lot more familiar with it. So far so good.
Yeah.
What is the complex code?
So the question is, what is the complexity of the code? Any takers?
I think for generating the permutations for the consonants, it will be the consonants number of consonants factorial.
Yeah.
And the number of vowels factorial. I mean, for the permutations of vowels. And then again, so is it a multiplication here or addition?
The final answer that you have is, so you will be generating C factorial first, you will be generating V factorial next. Those are like the combination generation scenarios. And then you will be interpolating all of them. So that will be C factorial times V factorial. So it is this to generate the consonant, this to generate, actually it's not C, but it's actually C plus 1 factorial, which is not a big deal, but it's still C factorial. And then plus it is actually, you will be, for each of those C plus 1 combinations that you generated, it will be, you'll have to multiply that, right? Because you are doing an interpolation.
Yeah.
Correct? Awesome. So no, it won't be n square, right? It will be because of the way this works. It's more like it will be a factorial option. So this is good. Now, if I were to, I think one of the, I don't know did I ask the questions? Yes, I asked this question already in the thing. So the question that I have in the thing was that if I give you like a set of letters like A, B, C, D, E, F, G, H, or something like that with some duplicates, okay? If I ask you to generate a set of values with all vowels together, okay, then I ask you to generate something with all consonants together.
Would
a letter can either be a vowel. A letter can be all vowels. I mean, a letter can be a vowel or a consonant, right? So let me repeat the question. So the goal here is to, my question is that this will generate a set 1, and this will generate a set which is set 2. Will set 1 and set 2 be the same?
The same meaning?
Identical.
Yeah.
If you keep all the vowels together, then would all the consonants be together? Is a question. Shashank says no, and Dev says no. Why not?
Because you can have a vowel surrounded by consonants, right, in set 1.
And you'll have consonants surrounded by vowel in set 2. Fantastic. It's just something that it's more of a gotcha question, not really like, it's not something to check smartness of people or something, but the goal here is that think carefully as to how the arrangement will work, because it's very logical for you to look at this and say, well, if it's vowel, it's vowel. It's consonants, and it's consonants. If it's not vowel, consonants. So why not it be the same? So I've seen people fall into that trap, so that's why I just threw it out there. All right? Any concerns so far on this question?
Actually, the one thing I was going to ask you, but you intuitively answered is, do you mean both vowels and consonants grouped together, or instead of vowels together, consonants together? Because if you had said, okay, vowels can be split up, but consonants are kept together, then it's a very similar solution. But you were talking about two groupings, and so, okay, that wasn't clear from your question. That would have been what I would have asked you.
There you go. You could also have a scenario where you can keep all the consonants together and all the vowels together, and that will be essentially the set 3 will be a subset, a full subset of set 1 and set 2. Because you will have scenarios, in the third set, you will have no scenarios where a vowel will actually split a consonant or a consonant that will split a vowel. Okay. Awesome. This is good. I like it. I like the participation. I like the energy level. This is nice. Let's get to the next one. Let's go. This one is given a string that only contains the letters A or B. Your idea is to write a compress function, which will actually take a sequence of repetitions and just condense it into a number. So BAAB will actually become BA6B. Any thoughts from people who have not spoken yet? Just checking. Going once? All right. Floor is open to people who have not spoken, who have been speaking as well. Go for it.
I was thinking.
Hey, Sandeep, go ahead.
Yeah, of using 2 pointers, and one stays on. One keeps track of the previous letter, and other one keeps track of the count of the. I'm sorry. One keeps track of the number of. How do I put it?
So, in case folks are struggling, Sandeep is trying to come up with an in-place solution to do this. Which is interesting.
Can I run through an example like it is given?
Yeah, go for it.
Yeah.
Go for it. Yeah. You can type on the coder pad.
Okay.
Line 115, 116 is free, so yeah, go for it.
Okay.
Whoever is on that dark pink on unnamed in the coder pad window, can you please rename yourself, because I really don't want to say he who shall not be named when I'm writing to you. All right.
Yeah. So you have 2 pointers, and both start at B, and we move. Say we call them pointer 1 and 2. We move pointer 2, and once pointer 2, the letter pointing is different from the last letter. We make a note of B, and that signals that the next character has begun, and we move pointer 1 to A, and now and there's actually a counter too, which keeps track of each
pointer
letter.
1. So one of the ways I do pointers is like I do V for pointer 1 and caret for pointer 2, right? That's like
Okay, yeah.
Neat, huh? Go on.
And once we go to a new character, we set the counter to 0. And now we keep moving this counter until we reach the next alphabet. And once we reach the next alphabet, we and for each time we move, we do a counter plus plus. And once we reach the next alphabet, we note down the number, and attach it. I wasn't thinking of using an in-place thing. I was just thinking of using an extra memory where I just put the current letter and the number, which is the counter.
Okay, because it's like when I heard you say 2 pointers, I assumed you were doing in place, but you don't need 2 pointers if you're not doing in place. You don't need 2 pointers, right? You can just do it with 1 pointer.
Yeah, that's true. Just keep a variable which tracks the current alphabet.
I created an output, character array, and then you just kind of, when you see a new character, you output it, and if you see the same character again, then you just keep incrementing the count, and then when you see a new one, you spill out the count, and then you put out the new character, setting the count to 0.
Hi, this is Dave. I have something to add.
Go ahead, Dave.
Yeah, thanks. So what I was thinking is we could have 2 pointers, one a read and one a write. So the read pointer will take the character and it will keep going forward until it finds a character that doesn't match that character, or it reaches the end of the string, and it will keep a count of that. Once it reaches the end of the string, or if it finds a character that doesn't match the previous character, it'll halt there, and the write pointer will write that character, and it will write the count in the next box, and then it will move ahead. But there is one catch to this: if the count is greater than 9, then basically we're writing characters. So we have to. So basically, have to use the same algorithm for converting number to a string, and then reversing it here. Does it make sense?
So far, so good.
So if it is like BA 100 times, then it has to be like BA, then 1 character 0, character 0. Right? Because the count will be an integer, so you have to convert it into array of characters and copy that array back to the array where we're writing over.
Okay. Anybody else with a concern? I mean, this algorithm so far, you have great work in terms of trying to do this in place. That's good.
Yeah, I think the one suggested by Pamela is good enough. Like just maintain. I mean, as you're incrementing through the string, compare the consecutive characters, and if they're
very similar. They're very similar algorithms. It's not a whole lot different, but I think the one that Pamela's algorithm implicitly assumes that if I just add a number into like a string buffer or something, it automatically gets serialized, it gets tokenized into number. So it's fantastic. They've actually went the extra mile of actually getting the numbers, converting it, and all that stuff. So I love the attention given to that one. So that's great. Any other questions? I think there are 2 problems at this point of time that have not been touched on. So I'm just curious to see what if folks are actually looking at it from like a problem aspect. And in an interview, if you solve like both solutions, whether it's Pamela's solution or Dev's solution, there are like a few or at least one missing item in both solutions, and possibly 2 missing items. So what do you think?
When the count is 1.
Sweet. What happens when the count is 1?
Yeah, when the count is 1, you just write once, and you leave it there. You don't write a number there, basically.
Yeah, actually, that's what I had written down on mine too. Is if the count is 1, then you don't write the number. And when I changed characters, I always wrote the character out. So.
Fair enough. So in your written algorithm, in your notes, I'm assuming you've written that. But when you explain this algorithm, I was specifically looking for you saying that if the count is greater than 1, then flush the count. I didn't hear you say that. And
I didn't say that. Yes,
I get it. In Dave's algorithm as well, the same piece was missing. There is one more thing that is different in both of your solutions now. So Dave, in your scenario, if you miss the count 1, you will actually run over the buffer, right?
If I miss the count 1,
if you include 1, if you start printing B1, right, instead of B, you will actually run through the buffer and you will overwrite letters, like your pointer 2 will overtake your pointer 1. If you don't take care of the count.
You're saying if there is a single B, character B in the string, is that what you're saying? As a test
if there is a single B, and if you do not actually handle it, if you do not handle the count properly, you flush the count onto that one, you will be overwriting characters that you have not seen yet. In Pamela's solution, since she was actually doing a string builder and a separate space, she doesn't have a problem there. I mean, it's still an ineffective solution, but it would not create garbled results. I mean, it will say B1, A1, C1, D1, which is fine. Your case, it will actually run out of string space.
No, actually what I was thinking is I'll have the right pointer point to the original character, right, which was there. So it'll basically be writing to the same place. You won't be, it's always copying the same character there.
Not really, right? So your B is at B, and then you will put the 1 where? To the right of B, which is a character you have not seen yet.
Yeah, but the 1 won't be put, right? Because it is,
again, I am premising
you've got to maintain the count separately.
Yeah, I understand that. All I'm saying is that if you do not check for the count equals 1 scenario and you mess this up, Pamela's solution will still work, but it will not produce right results. Your solution will actually run over the buffer. That's all. Nothing more than that.
Yeah,
there is still one thing missing in both your solutions.
The empty string?
Not really. Go on. Not empty string. But that's a good catch as well. Not the empty string. That's not what I was thinking.
May I try? I think if the last B is not there, the previous solutions will not be able to print the numbers. Is that right?
Fantastic. You guys mentioned that you will only flush when you find a different character. What happens at the end of the string?
Oh yeah, actually yeah, I mentioned that you have to go. You have to move the read pointer till you match a different character, or you find a different character, or you reach the end of the string. So
okay, I missed that when you said that. Then so good work, Dave. It was not what I heard in the first solution. As an interviewer, I would be very keenly looking at these are the things you have to mention. Like, I want you to handle the 1 scenario. Okay. I want you to actually tell me that at the end of the string, what will you do? Like, how would you end? Because you cannot always assume that a different character will be the triggering point. I mean, the string will end at some point, and you will actually not handle the last one. That's actually a very common production bug, where people actually are trying to, for dedupes and things like that, they forget to flush their temporary buffer.
I see. Yeah, thanks.
It's caused so many bugs. So it is an interview, interviewer will be carefully watching for that particular thing. So fantastic, Oli, good job. There's one more.
Vivek, I didn't get what you were saying. Like, aren't we doing a for loop and then checking, aren't we doing it for the entire length of the string? That's what we'll be doing, right?
Yes, Sirisha. So so the solution, let me take a step back and explain the solution, the way it was laid out. The way the solution was laid out is that I will go look at the first character. It's a new character, like I've not seen this character before. Then what I'm doing is that I'm putting B into my system, and I'll look at the next character. If I find the same character, then I'll increase my count to 2. Then I look at the third character. If I find another B, I'll increase my count to 3. Then I look at the fourth character. If I find an A, which is a different character, then I will flush the count, I will flush the new character, and I will reset my count to 1. That's what I heard.
0.
Count to 1 because you flushed A. You've flushed A, right? So you flushed the count, you kept the count to 1, right? The problem is that if I have like 20 A's and that's it, the string ends, when will you write the value 20?
Oh, that's what I was saying. If we have a for loop, so we will say that the main counter is less than the length of the string, then won't it terminate in that case?
The loop will terminate. That is not the problem. The problem is that my string at this point, after I'm done with the loop, my string will actually simply say A. That's it.
So for that, I'll be maintaining another counter in the for loop, right?
Correct. And that counter is there. So you have a global variable called count, which actually has the value 20, and you have a string that contains B2A. That's it.
We can have another if block saying if
we have to add, correct. You have to add that. That is correct. You have to add a termination, the final. I think the point that that Dave actually caught in his code, and the point Oli was bringing up was that when you are actually doing this kind of you're aggregating data and collating data, you have to remember what is the end state, what is the final step that you have to do. You have to write the 20 into the string, right? That may be missed. And since the writing condition in the original algorithm that was discussed was that if the characters are different, only then I will write. In the last scenario, it's not characters are different, the string ended.
End of the
so
string.
The last sequence will not be printed out. And so, as Avdesh mentioned, it's a very easy step. You just have to say that it has to be, you just have to do a if check. It's trivial. I mean, these things are very, very trivial, but it's a very common production bug. And kudos to Oli for like bringing that up. Great job. All right. There's one more thing that's missing, or it's not discussed. It's not really a problem, but it's something that has not been brought up yet.
Decoding.
Not just decoding. How would you handle? Let me give you an example and see if how would you handle a situation where my input string I'm on line 120 is. What do you expect when I encode this?
A2, B2, C2, D2. Yes.
Is it compressing? No. Then why do you care? You talked about the scenario when count equals 1. What about when count equals 2? Would you want this as A2, B2, C2, D2? Or would you prefer it to be?
I think we need to also check that the compressed string length is less than or equal to or less than the original string.
Actually, Karnish, you don't need to do that at all, because what you need to do is, since you're doing it, we are supporting mixed mode, right? So you can do that. The only thing is, just like how you had, if count equals 1, don't bother, just let it go. We got this. If count equals 2 and you have a different character, you just have to write the A back. That's it.
Right.
I mean, you don't put the count. You actually put the letter back, and you're good to go. Again, it's not a big deal. It is right. A2, B2, C2, D2 is the right answer, but it is something that we have to ask ourselves whether it's like something that needs to happen or not. And again, that's what it is. Again, the question is that we're trying to compress, right?
Yeah.
So anyway,
more than 10 characters. Then we need
if it's more than 10 characters, Dave actually mentioned that. He said that he's gonna find a clever way of actually dividing by 10 and then inverting it so that he can actually say it will be A10. If there's 10 A's, then he will actually say A10. If there's 100 A's, then he'll say 100. What if I have like I don't know a million trillion A's, which is like probably more than what your 64-bit integers can hold? What do you do? There is a question there. I think that's a good question as well. Is that at some point of time you will run out of like rotation space? Like let's assume that you can only store 2 characters, not 3, right? It's A99 is all you can do. Then the expectation would be that after that you will again do like a A2. If you have 101 characters, you do A99, A2. I think it was asked in the comments. I don't know if you guys had the chance to read the comments, but I think I mentioned that. I think Dev Jyoti had asked that question, saying, is there a range? Can it be greater than 9? And then I just mentioned as a passing saying like, yeah, if your limit is 999, then you need to do it as like A999, A100 if you have 1099. So I mean, it's again another thing. If it may come up as a candidate, I'm expecting you to ask that question about like, do I have a restriction in terms of the number of repetitions I can handle at a time? Should I have that? And if the interviewer says like, no, you're free to go, then you should say, no, but anyway, there will be a repetition restriction at the int level, like max int or something, right?
Mm-hmm.
Right. So that's something that you should be asking for. All right, I think this was an awesome discussion. Love it. All right. So I am going to skip 5 because it's a very common interview question, and we'll jump into 6. The 5 question is like find the longest palindrome in a given string. Do you guys know what a palindrome is?
Yeah.
I looked it up and found out.
So the reverse of the string should be the same as the string.
Correct. Like madam is a palindrome. Eve is a palindrome, where the starting of the string and like if you go front to back or back to front, it's the same. Now, the one key thing is that there are 2 types of scenarios in a palindrome. One is even length palindromes, where there is the first half actually mirrors the second half, and then you have an odd length palindrome where the center character essentially is the same, and the left of center character and the right of center character is mirror. And there's a O of n time solution available for it. It's fairly simple, dynamic programming. Look it up. Geeks for Geeks has it. It is an interview question. I would have loved to take the time to do that, but I'm more eager to solve question 6 and talk about it. So I'm going to skip 5. Is there anyone who disagrees? 6 is a much more fun question, just FYI. All right. We've got about 14 minutes to go. So question number 6. How many of you use any of these IDEs like Atom or Eclipse or anything? You would have noticed that they have this concept of finding a class. And when you find a class, you can actually type like specific characters. You don't have to type it fully. For example, if you had like an aspect clone mapper adapter, you can just type ACMA and it'll find a class because it actually searches the capitals alone. You could be a little smarter and say you could say A capital, S lowercase, C capital, L lowercase. It'll still match aspect clone whatever, and things like that. It's sort of a search in a sort of a different way. So the question for you is that if I give you a string, like the search string, and a list of tokens like so, can you give me the subset of the tokens that match the search string, where the definition of match is what I provided? Easy? Is the question clear?
Yes. So basically, you'll take each token in the list and have a function to compare the token with the search term, right? So
And
it's about
that function is what function is what I want you to write.
Right. So the function. So what my idea is that you'll have 2 pointers to compare. One pointer will point to the characters of the search, and the other to the token. So you kind of will iterate through them. So in a loop. So the first condition is that both characters match, in which case you'll just progress by 1 in both pointers. And there is one more condition in which the token has a capital letter which doesn't match the capital letter in the search, and in that case you just exit from the loop, right? Because you don't. It basically
the first. So the couple of ground rules, right? The tokens always will start with a capital. It's camel cased with mixed case notation. So first letter is capital. Then you could actually have single letter words. I mean, you could just have like, it could just be AC mapper or something. It's possible, but it doesn't have to have, the lowercase letters need not be present, but you'll always have, it has to start with a capital letter. That is one. Your search token, obviously, by definition, also has to start with a capital letter.
Okay. So if you take the example in which there's ASP and there's aspect clone mapper adapter, in that case, you have the read pointer starting, the pointer starting in A and A. They are the same. So step 1.
Okay, let's go to the Etherpad. I am on line 124. So I'm going to, I picked a different word, sorry. I picked the decorator factory instead of the mapper factory, but it should still be fine. So this is pointer 1.
Yeah. So
and
this is the simplest case in which both pointers will move until ASP runs out of characters. And in that case, you'll return true.
Yep. So let's go
right.
with this scenario.
ASPD, yeah. So in this case, you have a mismatch at E and D, right? So you'll keep incrementing E until you either reach the end of the string, or you find the character. You find a capital letter, basically. Right. So basically, keep incrementing E until you find a capital letter or you reach the end of the string. Now, if you reach the end of the string, then you have to return false. It doesn't match because ASPD is not fully covered yet.
So if you reach, no, so I don't understand. So you match A with A. I'm just following. Yeah, okay. Just for in the interest of everybody else as well, right? So A to A. So if I go, next one is S. I got S. I went to P. I went to P. So I'm good. Yeah. Now I went to D. Obviously, D did not match the E.
Match E.
Now what am I supposed to do?
So you keep the pointer D and you keep incrementing the pointer E. Okay, until you reach
D.
Yeah, D. Now D matches that. Okay. So
in this case, it matched. So let me call it. This was C. Okay, it didn't match. Okay. Now what?
So now both are capital letters and C and D don't match. So you return false, right?
Okay, so if this is a capital letter, you're going to do something. The behavior is different. I mean, I see what you're trying to do, but I'm not sure if you're.
So I had this question in the. Sorry, I had this question in. If you go to the web technical Thursday.
Go on.
If you go to for question 6, what will be the search string ASP can return for this one, right? So there, that was my question, right? If there is a after C and it doesn't match the M in mapper, will it still return? So based on that, that was my conclusion.
So A will actually fail because it'll fail because it doesn't match with mapper. That is correct.
Okay.
So n square, I think. If you have to go.
One solution.
No, one thing. Karthik, can you go ahead?
Yeah, I have a work one solution. What I would do is I will create a hash map with key as a combination of, for this particular example, a aspect directory factor, right? Key as ADF and value as a list of tokens. And out of those tokens, one is aspect directory factory, and whatever other tokens comes up with the caps letter ADF, those I will keep in that list. I will pre-process and generate one dictionary. Generate one hash map with the key and the values. Then whenever I get request for like ASPC, search for ASPC, I will find the value A and C and the caps letters from this, uppercase letters from this, and I will search those in my hash map. So by which I can get it with one operation.
Dishan, yes, using regular expressions is like a cheeky way to get this going.
Vivek, I think one solution I'm thinking about using a tree like a structure or a trie where I can have A as a parent, then S as a children of A, then P as a children of S, and just keep following that. So every following character is children of previous character. So when I get ASPC, so I just start from the parent, like root node, and keep traversing down to the tree. And I just follow the whole tree starting from the node. And if every character matches, then I return the whole complete structure till the leaf node. So yeah, I'm not.
So Avdesh, I think I am not following what you're saying. I think you're onto something. So is there anyone here who wants to like poke into like a tree-based solution?
Yeah, so you could split the tokens based on the word capitalization. You could split the tokens and then have each word as a node in the tree, and then so it basically a trie kind of structure. So if you have aspect decorator, and then something else, aspect factory. So you would have two children for aspect. One would be decorator, other is factory. So you, so basically, if you have a trie-like structure, but instead of characters, you have a string in each of the nodes, then probably you could find out where exactly the word, I mean, which, so all the children you could parse and then print out the list.
Awesome. That's great. That's great. Anyone with a did people understand what that is?
Yeah. So I have. I mean, you can enhance the trie in a trie data structure in a way where the capital letters have a pointer to the next capital letter in the trie block. Like in two types of pointers where let's say you have ASP. It's like a regular trie would have A child would be S, and then the other child would be P, right? But when you get to a C or a D in clone and decorator, right, you have a direct link from A to C to enable the AC kind of search, capital A, capital C search.
See, I think, Gaurav, one of the simplest things you can do, I think, if I just follow your logic and algorithm around, is that what you'll do is you will take the entire string that comes to you. You'll insert it into a tree just like how you do trie.
Mm-hmm.
Okay. So you will actually in this example that we have, you have a bunch of everything begins with A, right? If you look at the thing, everything begins with A. So the trie's topmost node will contain A.
Mm-hmm.
Then you will actually contain B, D, N, and S. Right, because there's two aspects. So you will have A with S, with P, with E, with C, and T as different links, and you can create that. Now the fun little thing that you can do is for every lowercase letter, for every small letter, and even for the capital letter, you also create an additional link to the next capital letter. That's it.
Yep.
And now you've created a graph. Right? Does that make sense?
Yeah.
Yeah, it makes sense. Yeah.
So now what you've done is you've created a graph, and once you have this graph in place, all you have to do is, given your current situation, you just traverse the graph to a point. If you are unable to traverse the graph, then no object found. You are able to traverse the graph, and there are children in the graph. Then all you have to do is every children of that graph will be the answer. Okay. You traverse down and you get the answer. There are some complications here because since you skipped, right, you don't know the path, so you have to traverse from the root for all of those, right? Now just because you said AC, right, it will be abstract whatever factory, so you would have missed the words like abstract clone mapper adapter, right? So you would have missed the words SPECT. So you have to actually, when you do the traversing, you have to go start from the root, and that's so what you'll end up doing is that each leaf node will contain the full data. That's the only other thing. Okay.
So of the two solutions, which will be better? Because one of them uses order of n, and the other uses extra space. So I believe with the trie you'll be using extra space, right? So how do you evaluate which one is the better one?
Well, I mean, these are two different approaches. Depending on what you're trying to do, that might be a different story. The biggest thing between time complexity and space complexity is that there is a trade-off. So if I can pretty much guarantee that the IDEs that you're using is not doing like a sequential search. It's probably doing some sort of a trie-based approach or something else, which is expensive in terms of memory or space, but it's actually not that expensive in terms of time. Usually you're not looking at thousands of symbols, so I'm not sure if maybe it's doing linear search as well, because given that, and how many tokens are going to be there? Like 100, 200? You'll be able to go through that quickly. So in this case, it probably doesn't matter. But if this were to be like a search that you're trying to do on the Amazon's product catalog, for example, right? I would spend the time to build the tree and the trie and do the gigabytes of data, because you do that once and you can keep querying forever.
Okay.
I actually had a production implementation of something that did repeated lookups, and it went from a database stored procedure to in-memory lookups, and we cut it down from 13 hours of processing to 2 minutes.
And you must have probably spent like a couple of days to do that, but even then, over time, like in 3 or 4 runs, you've got the time back.
Well, less than 3 or 4 runs, because it was a batch mode. It was batch mode. So basically, instead of using the database solution, it was doing. I took all of these tables that had all of these things that I was looking up because they were repeated lookups, and put them in height balance B tree, and it was a lot of work and space to create that, but the time compressed incredibly.
Awesome. So that actually, looking at the clock, we have kind of run out the time. So Deshaun, I know you wanted me to explain this in a diagram. It's going to be a little hard. I'm terrible at drawing, and the text doesn't really work.
Some of the regular expression implementations are actually exponential. They do backtracking.
That is true as well. Exponential, the regular expressions are they're cheeky, they're neat, but they actually are the cost is hidden from you. All right. So what I'm going to do is I'm going to park the session. I'm going to be available for another 10-15 minutes for additional questions.